Tonight we are talking about Lesson 8, Solving Trig Equations. To evaluate an expression means to substitute a given value in for a variable and evaluate. Evaluate the following. So this is kind of bringing it back to reviewing how to solve equations. So if we have 3x and we're told that x equals 6, we're substituting the 6 in for x. So 3 times x gives us 18. Oh. We know this because instead of putting x, we put 6. So our solution is 18. In number 2, it's a little bit more complicated, but we're substituting -6 in everywhere we see an x. So we have a -4, and instead of x, we've got -6 squared minus 7 times not x, -6 plus 2. And we want to know what that equals. Well, we're going to put it in our calculator, and we get -100. So that is our solution. So solving sine, cosine, and tangent equations. Sine, cosine, and tangent are trig functions that are related to triangles and angles. We can evaluate angles, legs, or hypotenuse just like any other expression. When evaluating a sine, cosine, tangent, we must remember that the value we substitute in the expression represents an angle. We have to check our mode to make sure the calculator knows what measure we are using. Always use degree mode, at least for this course. That will change later on in your education. We are going to ignore these two lines. So evaluating the following. We kind of already did this, but making sure that we drive home this point. So we have sine of 52 degrees. Well, we're going to put it in our calculator. We're going to turn on our calculator. And you can do this on Desmos as well. Check it in lesson 6, I believe, if you need help for Desmos. We're going to go to mode and make sure that we have degree highlighted. If not, you got to push enter, and then you have to go back to your original screen. We're going to type in sine of 52, and we don't have to put the degree sign because the calculator now knows that we are using degrees. I'm going to push enter, and I get this value. So I'm going to put 0.788. In these problems, it does not tell us what to round to, so we are just putting until we see a 0. Now pause the video and attempt 2, 3, 4, and 5. You should have gotten something similar to these. Now looking at number 6. Number 6 gets a little bit more complicated. So to review, the definition of tangent is opposite over adjacent. So according to the problem that we were given, if we have a right triangle and our angle that's identified is 90 degrees, we're talking about the only right angle that's in that triangle. You cannot have 2 right angles in one triangle. If you did, it would be half a box. 2 of the sides would never meet. Also, tangent's talking about the opposite and adjacent, not the hypotenuse. So the opposite side that tangent talks about would be the hypotenuse, and that is incorrect. So for number 6, because it's 90 degrees, it is not possible to evaluate number 6. Solving equations. To solve an equation, it means to simplify. All the operations to get the variable by itself. To undo an operation means to take it the inverse operation. The inverse operation of addition is subtraction. The inverse operation of multiplication is division. And the inverse operation of squaring is taking the square root. So for number 1, we're solving the following equations. So again, taking it way back to solving regular equations, we're going to subtract 5, and we end up with 3x equals 9. Divide by 3 to get x by itself. X equals 3. So the same thing for number 2, just a little bit more complicated. We're going to subtract 4 from both sides. And we're left with 2x squared equals 72. Then we're going to divide by 2 to keep on getting closer to x being by itself. These cancel out. I'm left with x squared equals 36. And then I'm getting rid of the square root, or the square, by square rooting it. And I get x equals 6. So that is my answer. So now we can solve equations involving a sine, cosine, and tangent. like any other equation. Inverse operations of sine to the -1. Cosine is written as cosine -1. And of tangent is tan -1. For some values, there will not have a solution. So just mark that out. For some values that there will not be a solution. So for number 1, we're doing similar to what we did in, I believe, lesson 4. So we've got sine of x equals 0.6. I'm going to take the inverse of sine, and what I do on one side, I have to do to the other. These cancel out. I'm left with x equals, I'm going to go to my calculator or Desmos to figure this out. So we're still in degree mode, and I'm going to go do second sine to get the inverse. I'm going to type in 0.6, and I get 36.8, and let's go ahead and round there. And these are all in degrees. Now, how to check this? I want to save this whole number, not just the 36.87. I want the whole number, and I'm going to store it for x. Now I want to check to make sure my value for x gives me this 0.6 in the problem, or the equation. So I have sine of x, which again, the calculator has saved that big number or big decimal for x. Go push enter, and I get 0.6, so I know I'm right. I'm going to do number 2. Cosine of x equals 1.5. I'm going to take the inverse of cosine. Going to take the inverse of cosine on the other side as well. I'm left with x equals, and I've got to figure out what this is. So I'm going to second cosine, and I'm typing in that 1.5. Well, this is saying that it's not possible. The domain is not right. So let's look at this. If I wanted to change 1.5 into a fraction, it would be 3/2. And cosine definition is cosine of x is opposite over hypotenuse. So we have our right triangle, and it doesn't matter where the x is. This is telling us that the opposite of the angle identified is 3, and our hypotenuse is 2. Well, our hypotenuse can't be smaller than one of our sides. So this cannot be a correct right triangle. So our answer is not possible. For number 3, it's kind of like number 1. Got tangent of x equals -6.7. We're going to take the inverse tangent of both sides. I'm left with x equals, I gotta figure out this value. So I've got inverse tangent of negative 6.7. And I actually get, and I know my calculator's messed up, I get negative 81.51, so on and so forth. So I'm going to put negative 81.5 degrees. Now pause the video and try 4 on your own. You should have gotten something similar to this. Now for 5 you're solving it, so you've got 4 minus tangent of x equals 4. I'm going to subtract 4 from both sides, so I have a negative tangent of x equals, well, 4 minus 4 is 0. I got to get rid of this negative out here. So I'm going to divide by 1, negative 1. These cancel out. I'm left with tangent of x equals 0. Well, thinking about this, I can type it into my calculator and I'm going to get 0 degrees. But in any triangle, regardless if it's a right or not, if one of my three angles are 0, it's not a triangle anymore. So if, let's say this angle became 0, then I would just have a straight line. Or this angle, this side would come all the way down, and it would just be a straight line like before. So this is not possible. Now, pause the video and try 6, 7, 8, 9, and 10. You should have gotten something similar to these. Now for number 11, I want to talk about. Number 11, we are going to simplify. So we have negative 54 plus 2/3 times cosine of x equals negative 16 over 3. Well, I'm going to plus or add my 54 to get rid of it. And I'm left on this side with 2/3 cosine of x equals 146 over 3. So now I'm going to continue trying to get x by itself. Divide by 2/3. Divide by 2/3. These cancel out. And this is essentially saying 146 over 3 divided by 2/3. Where I'm going to change this division to multiplication. And I've got 146 over 3 times 3 over 2. And then I'm simplifying that. Once I do this, I get 438 over 6, which turns into 73. So I have cosine of x equals 73 taking the inverse cosine of both sides. These cancel out on the left, and then I'm left with x equals and whatever that side equals. Well, when I put in the calculator, it says error. Why do you think it's error? Well, the definition of cosine is adjacent over hypotenuse. Well, if these two numbers are supposed to be equal a whole number, that would mean that our a would have to be bigger than our h, so it could go into the adjacent side or the measure of the adjacent side evenly. So creating a positive whole number cannot work when we're talking about cosine. So our x is not possible. And then we are ignoring number 12.